function. So you know what a function is. We've been doing that for the past week. Now, believe it or not, functions have children. If a parent has a child, the child will somewhat look like the parent. In the same way, kind of grasp that idea about a function having a child. The child will look like the parent, but not exactly. So let's talk about parent functions. The most basic function of a family, examples: linear, constant, quadratic functions, cubic functions, trigonometric functions, logarithmic functions, polynomial functions. There's all kinds of functions. Try to fit that in there. We're going to go over most of these types of functions in this class. It's going to get crazy in here. The four basic functions, okay? Now, let me take one of them. Let me take a quadratic function here. This is the parent. The parent's always going to look like that. F of x equals x squared. That's the parent. Look what I'm going to do. When they go to my desmos.com graphing calculator that you'll use later on today, it's called desmos.com. Let me put on projector mode so you guys can see it a little better. Let me type in f of x equals x squared. I'm going to type in the parent function of a quadratic. Just watch me do it. F of x equals x squared. Hit the square button. I'm going to hit this one too. It's square. So there's f of x. Remember, f of x just means y. Remember, we're on a higher level now. Function notation. Y equals x squared. There's the graph. Watch this now. That's the parent. I'm going to allow the parent to have a child. And look how the child will look like the parent, but it's not going to be exactly like the parent. Watch. Let me copy and paste this puppy. I'm gonna put a 2 in front of the x squared. Watch this. Look at that. So the blue graph is the child. The red graph is the parent. Okay? Let me have the parent have another child. I'm going to add 5. Actually, you know what? I'm going to subtract 5. Look at the green. So x squared minus 5. So the original parent function, f of x equals x squared, it's on your paper, is in red. I put a 2 in front of the parent, so the child became blue. That's it's a child function. And then I put a minus 5 after the x squared, and then you got the green one. So, long story short, we're going to be involved with functions and then transforming them any way we like. We want to make the parabola fatter, skinnier. We want to move it here, move it there. We can do all sorts of stuff. We want to flip it. We can do stuff like that. We're going to transform functions. Because the whole point of that is, if I look at phenomena and I graph it, and I want to describe it with an equation, I got to know how to manipulate functions to describe the phenomena I'm observing as a scientist. So, back to your notes. Second word. So we got parent functions. Next word is transformation. Write that down. A transformation of a function changes the size, shape, position, or orientation of a graph. In other words, you just saw me transform the parent function into two children a little while ago with the quadratic. I made one skinnier, the first child, and I moved the one, I changed the position of the second child, the green one. Okay? Next word. You guys are doing good. Translation. So translation is a kind of transformation. So you have transformation that describes any kind of change. Now, let's get into some specific kind of changes. One kind of change is a translation. A transformation that shifts a graph horizontally. If you forget horizontally, put a left or right arrow. And or vertically, put an up and down arrow. But does not change the size, shape, or orientation. So it's a translation, that's the fancy word for a common word, slide. You might want to put that in parentheses, just so you remember. Translation, all that, this is a fancy word for a slide. If you slide the parabola somewhere, you can slide it up and down or left or right. That's all this is. Down, left or right. So that's one kind of transformation. Let me translate that parent I had up here. I already did with the green one. Let me erase the blue one. So here's a parent. There's a parent quadratic. I slid the parent down. I translated down 5 units. Let me translate it to the left 8 units. What am I gonna do? Check this out. X plus 8. So what I did, here's a parent in red, and now in orange, I translated 8 units to the left. I put plus 8 in parentheses squared, and I moved it to the left. The green one, I moved it down 5 units. And the orange one, I moved the original parent function to the left 8 units. It's kind of weird because I put plus 8. You would think that's going to go to the right, but it actually goes to the left. It's kind of counterintuitive. Left 8, down 5. So the parent is having children. Let's go on to the next kind of transformation. That's called a translation. When you slide something, translation. Next one. Here we go. Reflection. A transformation that flips a graph over a line called the line of reflection. A transformation that flips a graph over a line called the line of reflection. So any number less than 1 but greater than 0, we're dealing with a fraction. Watch this. We're going to shrink it vertically. That means the parabola is going to get fatter because I'm going to shrink it. Watch this. Let me erase the child. Let me kill the old child, and let's have another child. Sorry for the violence. I know, that's sad. Give me a nice fraction, Ayala. Like a crazy fraction.
3/7.
I love it. Watch this. Look, I'm going to put 3/7 in front of the coefficient. So notice the child is in darker red. Okay. I took the parent and I vertically shrank it. So if I shrink this parabola, it's going to get wider. You see? That's called a vertical shrink. If I take it and stretch it, it's going to get thinner. So a vertical shrink versus a vertical stretch. Now, he's going to come on my video here, man.